Now dear students, we will try to understand different functions that are available in the math library. In the Vocui, as you know that all the libraries are already present online, so there is no need to add any library in the Vocui. But if you are going to practice this on any IDE, then you have to add the you will have the need to add the math.h library. So we have just declared, let's just start this. We have just declared a double x and a double y variable with the value 45 and 30.20. So the first function we are going to study is the cos function. I have already just written some notes over here. I will copy this and we'll paste over here, and we will study this one by one. So for checking the results of these trigonometric functions, we are going to use our serial monitor as we have done in our previous video. The first function we have is the cos function. It will return the cosine of the angle, and the angle that we will pass to this function will be in radians. So the result will be between 1 and -1. So over here, let's just save this and let's run the simulation to see that what will be the result of this function. So you can see that the cosine of number the value, or we can say that the 45.45 is the value of double x that will pass to this over here, and the cos of that 45.45 is 0.10. Let's say if we modify over here and let's write 45.45. now it will be more clear when you are going to see the result in the serial monitor. So cos of 45.45 is 0.10. So in this way the controller of the Arduino will calculate the cosine of the angle that we have passed. So the next we have the function, the mathematical function that we have is the fab. Is the actually the let's copy over here, let's cut. The fab are the floating point absolute number will return the absolute value of whatever number we have passed to this function. So let's say let's save this and let's run the simulation. Now you can say that absolute value of number 45.45. That what actually we do, let me just change this. Let's say it actually will convert the, if we have passed any negative value to this parameter, it will give the positive. Let's say if I write minus 10.5, it will give us the result 10.5. So you can see that. So absolute the f absolute calculates the absolute value of the floating point arguments. The next function we are going to study is the f mod, that is the modulus of the floating point. Let's paste over here. So f mod, the C library f mod function takes two argument. It takes two argument of type double and returns the remainder on division x divided by y. Basically it's a modulus function and it will give us the remainder after the division. So let's check this function, let's save this, let's run the simulation. Over here on the third point you can see that floating point moduli is 15.25. it actually divides x by y, and whatever remainder will be, that will be printed over here. That is actually calculated by this f mod function. So hopefully you have understood this function. The next function in the math library we are going to now study is the sine function. Similarly, like we have studied in the about the cos function, that will give the cos of the angle that we have passed. Similarly, the sine function will give the sine of the angle we have passed. So let's save this. Let's run the simulation. Now you can see that the sine of number that we have passed is over here. Similarly, if you want to calculate the square root, then you are going to use sqrt and will pass the value. So this square root function, the fifth function we are going to now study, will give the square root of whatever the value we have passed in its argument. So over here, square root of number that is x, that is double x, it's 45.45. so the square root of 45.45 is 6.74. let's just bring this up. Let's stop this. So in this way you can calculate the square root of any function, any value. The next function we have is the tan function, that will actually calculate the tangent of the angle we will pass into its parameter. So we have passed 45.45, it's actually the value of double x. So let's run the simulation, see what's the result. So you can see that the tan of 45.45, that is actually the value of double x we have declared on the very start of the code. The tan of that value is 9.67. so let's stop this simulation. So in this way you can use tan to calculate. Similarly, we have the exponential function, and let's just paste it over here. We have the exponential function that will calculate the exponential value of a number, and next we have the next we have the a tan function that will calculate actually the tan inverse of the value we will pass into its argument. So let's just paste it over here. So arctan or a tan is also known as the inverse tangent. So it will give the inverse of the value that we will pass into its argument. Similarly, we have the a tan function, and we have the logarithmic function, then log 10 function, then we have the power function, and then we have the scale function. Let me just move this all into the code, and we can then study one by one with their results. Okay, let's paste it over here. Let's save this. Let's run the simulation. Now till the fourth point, the sixth point, tangent, we have understood, that is over here. The next is the exponential, that calculates the exponential value of a number. So whatever value we will pass over here, it will return the exponential value of that number. So over here we have passed the double x value, that is the 45.45, and it have returned OVF, that is actually the overflow, that the number is that we have got is of higher value as compared to the data type we have declared. But the method to get the exponential value, the function will remain the same. The next thing we have the arctan, that is actually the inverse tangent. Over at 8th position you can see that we have passed 45.45, the value of double x, and the tangent inverse of that function is 0.59. Similarly, if we want to get a tan is actually the tan of y over x, whatever value we have in the first parameter divided by the second parameter, then we will get an a tan of that value. So the result of A10 is 0.59. Similarly, if we move further and see that the log of 45.45 or double x is over here, that is actually 1.66. Similarly, we have the log 10, then we have the power we'll calculate the x to the power y and it will give us the result. Similarly, and 13 we will get the square of any number, whatever number we will pass into this parameter, then we will get the square of that number. So these are just different functions that are available in the math library that you need to understand. These will be very helpful when you are going to do some calculations like calculating the speed or getting data from the sensor and using these trigonometric and mathematical functions to calculate the actual value that sensor have sensed. So hopefully you can also study these functions from the references that are available on the Arduino website. So hopefully you have understood the basic concept of the math library and the math functions that are available to us.